short. And so the goal is to finish this in like 20, 30 minutes. And then leave time for question answering, things like that, things that you would like to revisit even, some of the concepts, because Sachko agreed that you went over things quickly, which is of course a function of what we're trying to accomplish today, to just give a lot of ideas at that basic level, and then if you're interested, you go further. You got these pointers, but then we'll also have a chance to have Sachko explain in more details whatever we want to do, right? And so everybody is welcome to stay as long as Sachko can survive us.
Also, if you ever need help or advice, or you would like to chat about the projects that you have and you will have in the future, then please feel free to let me know. Okay, so one of the slides missing was when it makes sense to go from the word level to character level. I can give 2 examples from Brainly. One of them is the questions with formulas, like mathematical stuff, and mathematics is like 40% of content on Brainly. So something needed to be done for it, and so we have to train the models from character level. Another one is, actually it's not spam detection, but it's detecting like junk content. So they have a rule that an answer cannot be shorter than n symbols. And the purpose of this rule was for the people to provide explanations for their answers. But what people are coming up with is usually like lots of question marks and lots of like some character repeated 150 times. And while with question marks it was okay because they were embedding straight for question, like for punctuation. So, the words like of 150 A's were tagged as unknown, and there was some representation for it, but it did not say that the word is bad. So what we did is we ran 2 models in parallel, both word-based and character-based. The reason why not go exclusively to characters is because we introduce, like the model has to learn the concept of word by itself, and if you don't have enough data, you almost never have enough data. It's better to reuse this knowledge that comes with the words. And so 2 models in ensemble to predict whether a message is potentially spam. Okay, and this probably illustrates also the thing that in choosing the architecture, especially when you are running something in production, you really have an either-or choice. Usually, yes, training models takes time, but inference is pretty cheap for almost all the machine learning architectures, and you can afford running 2 things in parallel. There was one example, I thought I removed this slide as well, but luckily I have not. This is, at the end, bottom there is a link. This is a paper from 2015, I guess, I don't remember exactly, by one of my friends. They did sentiment analysis for Twitter posts, and they had a really limited amount of hand-labeled examples. So what they did is that they took a large corpus of unlabeled posts and they trained word embeddings on them. And then they retrained the convolutional neural network on the posts that contained emoticons. Because like a happy smiley is probably a like positive post and vice versa. Yeah, something is rebooting. Okay, and this is in general called learning with distance supervision, but it comes in many other like names as well. And then they did the final training on these hand-labeled examples. But then you need to balance, right? Like with early stopping, when your test loss starts going up, you need to know where to stop each of the steps. Otherwise, you will just erase everything you learned previously. And as I said, one of the things is not to learn anything new in general. And then there was a slide with links to further reading of convolutional neural networks. So maybe you have these courses as well in university. I'm usually recommending the course from Stanford to people, 231N, CS231N. They had to take down the video because of not providing these captions, the transcript for people who cannot hear, but if you want to, you can find it. And this is, so mostly these are CNNs for image processing. And also there are a few really cool tutorials on how to implement CNNs for text. And this is the paper from 2011. It's, I already mentioned it, it's NLP almost from the scratch. So they used two approaches to analyze text. One of them was actually with convolutional networks. And this is like this paper was one of the triggers that started all this stuff with deep learning in NLP. So I would advise you to read it. You know, even if you are curious only about the history of how science develops.
What's the name of that article again?
It's called
Natural language processing almost from scratch.
Yeah. Thank you.
It's the Journal of Machine Learning Research.
And now we come to recurrent neural networks. And I don't want to go into detail unless you insist. But what is the motivation of recurrent neural networks besides the fact that it's intuitively good for describing languages rightly? There is a sequence of words and RNNs model sequences, as well as there is a sequence of events like in user profile, and one follows another. The reason is that CNNs cannot model everything, and in particular in Brainly, there was a problem with incomplete questions. So a question is like, what's the square root of? Or the question that has like legitimate start and ending, but nothing in between. Like, could you please help me to solve this problem from mathematics? I need your help now. And if you train a convolutional network, it only looks at some window, and then every window looks okay. But in total, there is nothing. And so I decided to use a recurrent network, and it's like a loop in which this is the RNN already unfolded. But this is it. So one of its inputs is the output from the previous kind of iteration, and they are concatenated. And then the same thing as in usual neural network goes on. The thing why it's drawn this way is that RNNs never run in this kind of loop. They are in reality unfolded, and it is a like deeper neural network with the coefficients reused. And this also means that just like for CNNs, at least with default implementation of CNNs in TensorFlow, you have to pad your messages. If you have a sentence which is like 5 words, you are anyway padding it to some standard distance. And this can be, of course, the maximum length of the piece of content that you have. But this is not probably the best approach. You could create buckets by length and then run each bucket only padding to the number of elements in the largest item in it. So
how do we pad like sentences?
inserting some text, like you can insert unknown, or you can like, so images appended with zeros oftentimes. It depends upon what you want to achieve. In practice, I've seen quite a few systems that plan with unknown text, but in my opinion, it is better to reserve something else for it. And it looks like the recurrent neural networks can model the infinite length of items, but in reality it's not really so. When you have a really deep network, then you lose information when going from layer to layer, and especially when doing backpropagation. So this is called vanishing gradients, and it's been a known feature for a long time. For a long time it prevented training networks of any significant depth. But they came with the concept of gated units. This one is called LSTM, long short-term memory. And there is also one equally widespread now. It's called just gated recurrent unit, rule. And what you do here is that you also learn a set of additional parameters that tell how much from the previous step should be taken and how much should be put through the unit, how much should be forgotten. I have a link after this series of slides if you're interested in detail how it works. But even with this, there is a practical limitation on the memory within the recurrent network, and it's probably a few dozen, and with fancy optimizations it may be a few hundred things. So if you are training a character level model and you hope to describe the whole paragraphs of pages in the book, probably it's not the best approach. And if we have this problem, we can discuss afterwards what would be the best approach. And also, the RNNs became popular to a large extent because of their usage in automated translation systems. And quite recently, Google finally released its sequence-to-sequence library for TensorFlow, which is now almost stable. So the idea is that you feed a number of characters or words to the network, and then train it to output some other sequence, not just one number or one class. And in between, this is stored as the state of the network itself. You could say vector representation as well. And then there is some special tag, go, and it starts generating things for you, and at the end of the sequence, it generates the end of string. So this is used for translation, but also you could try doing autoencoderish stuff, trying to remember the text as a vector, and this is like a form of compression. And here are the tutorials on RNNs and also on sequence-to-sequence, and also a few blog posts that also from intuitive point of view explain, one more post on it, I believe that one. So, explain how it works intuitively, and there is this course also from Stanford, also with deleted videos on deep learning for natural language processing. And I think that's it. Yeah, thank you.
Questions?
Yes.
So, what software
So it's kind of generalization of logistic function if you have lots of mutually exclusive classes that you, yeah, here is it. So this ZJ is the log odds of a certain outcome, and you kind of make it the largest one dominate everyone else by exponentiating. How is it? Yes. So you, and then you bring e to this power, but then you normalize to the sum of everything. And so even if in logos you will have just a little bit of difference, then in probabilities, in normalized probabilities, you almost certainly have one probability. Yes.
Is it just this one function, or is it like there are other functions which can be also?
So this is the standard that is used, but it can be used only if you have mutually exclusive classes again. Because of this stuff. Otherwise, you train separate classifier for every class if the probabilities don't have to add up to 1.
Actually, I saw a formula somewhere in log. Maybe is it represented in log? Not in your slides.
Loss represented in log. And
But
there is generalization of loss as well. You just take y log p divided by the sum of like everything. So this is just for 2 classes, and there is a generalization for n classes.
I think for your question, I think the z is can be in log.
okay.
Is that what you're referring to here? E to the power zj, right? So is it that?
Yeah, this is kind of transformation that you go through to get normalized probabilities, but then you need to calculate loss as well, and the loss is this stuff with the logs.
I had one more question.
Yes.
In the neuroset, if we are taking with one middle layer, and there is output layer and input layer, is there a meaning to the number of neurons that are present in the middle layer?
Yeah.
If it's more, what does it mean? If it's less, what?
So if you could imagine the number of classes that you need to determine afterwards, and you say that each of these neurons can divide the space into 2 with a hyperplane, then more or less this will be some function of the logarithm from the number of classes that you need. It cannot be smaller because otherwise you won't be able to divide all this space into this number of classes.
So is there like we need to experiment with different numbers in the hidden layer? Or
Yeah, there are different heuristics, but it's better to start with the smallest number you can imagine, and then expand it and look at whether the performance on the test set got better. The only thing is that when you are using ReLU as activation function, you need to take into account that some of the neurons will die. They will go in below 0 region, so you need to also add sums for it. And also if you use dropout, if you are excluding during training some of the neurons, you should probably, in the first place, in order to reduce the overfitting, you should have this overfitting. So there should be something additional for it. There should be some redundancy in the number. But I think to me at least intuitively it is related to the logarithm of the number of categories that I can imagine. And usually it goes like this. We start with lots of inputs, then we go a bit narrower, and then whatever we need to predict. And this narrowing is kind of stuff from autoencoders that we try to compress the information.
So do you recommend TensorFlow than the other libraries? Python, for example, there's another library called Scikit.
So Scikit is more general, and it's high level in many regards. But if you want to experiment with the algorithms themselves, if you want to try to come up with a new flavor of recurrent group unit, then you need something lower level. You need things like TensorFlow. And in Scikit, you just usually you have estimator, and you say, does stuff for you. So if you need to do something fast or as a baseline for your own models, it's perfect. But if you want to invent a new architecture, you need tools to implement.
I didn't see support virtual machines in this presentation.
No.
Are they not good or?
Of course they are good. For a long time it's the only thing that worked. It's only that I needed to draw the line somewhere. I was afraid that we would run out of time. So yes, it's like SVMs with usage of kernel tree, etc. It was for a long time the only way to try to go from like non-linearly dividable spaces to where you can draw the line between classes. And it was and still is widely used. But this is like outside of the scope of the convention.
So I think, so to kind of like further the question or the responses, I don't think, I mean, if you're curious about like how deep learning kind of competes or compares to, I mean, my understanding is it really depends on the nature of the problem. So I wouldn't say one, like, you know, I would start with regression, logistic regression or something simpler. Because if it works, then computationally that's just best. So, you know, SVM to me, it's like when you're really dealing with like high dimensional data. And so, yeah, so I would go there. Deep learning for me is, so the one appeal or the motivation is that when you have a lot of, you know, computational, like if you're doing regular neural networks, you know, essentially as, you know, Sashila showed, that there are, you can imagine each of them having some kind of like a regression function, right? And you're combining or you're using all of these. So each of the neurons are really, you know, processing units. There is a limit to how much you can have, like how many processing units you have. So imagine like, you know, trying to build a supercomputer, right? There's a limit to how many cores you can get on your own, until you realize that maybe the better thing to do is what, you know, Google and Amazon and all that have been doing is have a huge kind of low-cost networks, but connect them in such a way that it results into. So deep learning allows you to create multiple layers, each of them with not too much processing, but through all this having, you know, layers, you know, it achieves, you know, computationally as good or better. So I think it really comes down to the data that you have, the kind of problem that you're dealing with.
Also, you don't have to choose either or. The best results are usually like given by the models that are ensemble models that combine a few approaches.
But I mean, the whole idea is to have a very accurate result, right? By using deep learning, the output should be more likely, right? More accurate than.
Yeah, yeah. And so for some time there was a kind of, it was not even a joke that neural networks is the second best approach to every problem. So now at least for image recognition it is the best approach. For language modeling and stuff like this, I'm not really sure. It probably depends upon the very task. But at least for a long time, Google Translate was, you know, based on statistics, like pure statistical system. But now, at least for most of the languages, it is based on the generative deep model. So there is movement towards it, especially since, as Chirac said, as you have the need for distributed computations, there is a limit to what you can do without distributing stuff, and then these network architectures for models are ideal candidate for making distributed.
But isn't it that if the data is not that feature rich, then we don't really need like image data has a lot of features. So, and we need to also classify them to be very specific. But if it is a general classification with the features that are not very rich, wouldn't be
I don't know, perhaps the richness of your features depends upon the level of abstraction. like when DeepMind taught these Go algorithms, they did not deal with the coordinates for pieces, they dealt with the image, and it was able to learn by itself. So the same with computer games, and perhaps it is similar with language, because you could preprocess data with like any language model that you have and come up with your own abstraction, or you could allow the model to learn its own abstractions. And it depends upon probably the amount of data you have access to. Because if you don't have that many data, even unlabeled data, then of course you should ingest more knowledge of your own into the system that you are training.
So for example, a spam detection, would deep learning be a good idea for spam detection, or even like simple models like nine-based work as far as I know.
But again, so spam detection is a war, and right, because there are two sides and they're competing, and lots of times I've seen the words like modified in the sentence, and it's okay if a human can distinguish. But then again, if you have a vocabulary, the vocabulary of a spam detection system is really large, because you have to take all these variants into account and all the possible intentional misspellings. And then you have the case like in Brainly, they have these long messages consisting of letter A. And then what do? Of course, you could try to come up with a set of heuristics that if the same letter is repeated more than 5 times, perhaps this message is bad. But how many rules like this would you have to generate? And again, how many rules like this you would have to generate every day if you are dealing with the real world spam? So, like, if spammers had choice from only the predefined vocabulary of words, then this would be a much easier problem, but they are creating. So I'm not sure what they use in production now, really. I was never working on systems like this, but I could imagine that it can be useful.
Jonathan?
Oh, I just had a question. So besides the TensorFlow online tutorial, which is interesting to do the layers, is there any recommendation for doing sort of local experiments with tensors? Because again, it has its own sort of architecture. Everyone's like, oh, it runs on this, it runs on that. Just something simple where I have a small enough set and I want to start figuring out how it works with the TensorFlow system.
How to work?
Yeah, so like, do you have any recommendations for how to do that? Like, is it like, oh, hook it up to an Amazon box, or do something
I would
locally?
install it locally, because really you don't need the GPU just to experiment with things. And now Google has this like $300 credit towards every new user of this TensorFlow in the cloud, or however it's called. But really this $300 will not get you too far. They first announced it for the Kaggle competition on video classification or something like that. And it was, from what I heard, just enough to run one experiment, and then the money was over. But I would do it locally. I would just install it. If you have Python, then it's trivial. Like through PIP, the latest distributions of TensorFlow available. Of course, if you want to do it like super optimized, etc., you should do it from the sources. But otherwise, I would just install it locally, install Jupyter, and then somehow try it.
And are you also asking about like the data sets?
Well, even, yeah, if you just had something where it's like, here's a clean thing to start with to sort of get a feel, get your feet wet with TensorFlow locally.
So I would start with the data sets that are freely available, but it really depends upon your interests. If you are interested in like convolutional neural networks and getting a feeling of how it works, you could start with MNIST, these digits. So these are images of digits, 28 by 28, one color channel, balanced classes. And there is also the one that's a bit more realistic. See Part 10. So this is the stuff that you can still be able to like train models on locally. So these are 32 by 32 images, 3 color channels, also 10 classes. And for language, I really don't know. I mean, there are so many corpora, you could download anything, and usually, people start with news. But anything you want, you could download the dump of Wikipedia.
Yeah.
We have stuff like the New York Times data
Oh,
from the
yeah.
lexical data consortium, stuff like that. That's a
We
standard
have lots
stuff.
of track data. It's got LA Times, New York Times. Yeah.
There are data from Braille, of course, right?
But I think in most of these cases, really, what you need is not just data, but assessment. Because you can run whatever you want, but then how do you know if it's any good? So you can do it yourself, or you can have something that's already been assessed. So you have labels to be able to then, if you're working on some classification problem, for instance.
Yeah, I mean, I guess sometimes when you're doing just go on embedding and you want to see how that works, or yeah, if you want to do like external evaluation.
Yeah, so if you just want to train embeddings and visualize, you could train them on any sufficiently large piece of text. If you want to do like language modeling in the meaning of trying to predict the next word, right, and being able to generate some sentences, you could start with the corpora as small as, works of Shakespeare. Stuff people actually do it. So yeah, it depends upon what you want to do.
So I'm still a little bit confused about convolution. So let's say once you split it up into a bunch of smaller images, what does convolution actually do?
It applies the same filter to every piece of the image, and then it multiplies the piece of the image by the filter, right, element-wise, and adds it up. And this is a metric of to what extent the piece of image is similar to this filter that you are using. And then this value goes to the next level. But convolution is basically this.
So you compare the image
Yeah,
how similar it is to.
yeah. And then
Like what is it?
so a filter is a grid of numbers.
Like for example.
So yeah, like a 2 by 2 with 1, 1, minus 1, minus 1. This is one filter to detect an edge, a vertical edge. And then the trick in the convolutional neural networks is how to adjust these values in the filter for it, because you start without any prior knowledge of what features you're looking for. So you start with small random numbers and you try to adjust them by tiny steps to match something that is a good predictor of the classes that we want to find. Yeah.
So, how do we run the TensorFlow on, like, we have GPUs in the island?
So if you have NVIDIA GPUs, new ones, then you install all this CUDA stuff, and then if you have Linux there or something like that, which operating system?
Linux.
Yeah, you just
So, I have worked with CUDA.
yeah you make sudo pip install TensorFlow -GPU, and it's installed, and then
So, you have to code in C then, or is there an integration with Python?
so yeah, there is integration from Python.
Okay, so I can like run commands on Python and ask it to be done on
Yeah, it's like not directly asked, but you build a graph and then you run it, and then it is done. There are some like technical things about what to do on CPU, what to do on GPU. If you're creating a variable, you want to create it like on CPU context because we want it in the RAM of the computer. But it's like, there is a part of the computer tutorial that covers.
More questions?
Okay.
So what I'm going to suggest, I actually have to graduation, but Sachko has agreed to stick around, and you can talk to him whatever you want to. It doesn't even need to be about deep learning. Sachko knows many other things.
Like at Google.
Maybe a couple more things.
I wanted to suggest if anyone is working on recommender system or is going to work on them, I could be here next time in autumn maybe and let's talk about it because it's the stuff I worked on the most, frankly speaking.
Yeah, we do have existing people, and there could be other people who are interested. So we can definitely announce that and gauge the interest. And frankly, for this also, I didn't know how many people will actually show up because it's like you can feel the campus is empty. But often it's a matter of the right time. I guess if we had done this a day early or a day later, it could have been different. Who knows?
Yeah, thank you all for being here. Thank you, Shirak, for organizing.
Well, thank you for coming here. So.